Hey everybody, it's time to raid my lab. So I'm not feeling awesome today, and I thought it'd be kind of fun to just grab a random tub. In this situation, it is my one labeled water, sound, light, and temp. And I do have some additional sensors other than these. But these are the ones that are in this tub. There are some multi-sensor kits that have other sensors. And I just thought we'd kind of poke around, see what's in here, and see what's interesting. We might even fire up a couple of them. Let's kind of separate this out, and I'll come back to you in a second. Okay, so the first three that we have are three that you're probably familiar with. This is the venerable DHT11 temperature and humidity sensor. Not very accurate. But these come in pretty much all the Arduino starter kits, and this is, a lot of you cut your teeth on this one as your first temperature sensor. Now, this one here actually holds a special place in my heart because it is this one that caused me to embark on a giant IoT project where I learned about pull-up resistors, and I learned about Node Red. This is actually the first sensor that I ever hooked up to a Raspberry Pi, first sensor I ever used on Node Red, and just sent me down a crazy spiral that has brought me to the place that we are today. The difference is that this one here is a little bit more accurate than this one, but this one can read faster than this one, and so this is considered a little bit better sensor, and I use, it's, by the way, on this it's called the AM2302, also known as the DHT22. So these two sensors are pretty common, this one much more so. I think these feel a little bit more industrial and stuff like that. So I use these occasionally when I need some broad temperature readings in a room. Now they do have this cousin, and this is called the AM2320. And the deal with this one is basically an AM or a DHT11. The difference is this one has I2C built in, so no bit banging required. These are I2C ones. I actually have never really used these. I don't really even remember why I bought them, but I got 5 of them cheap, so I have them. These are the generic 2320s. So that's a look at some temperature sensors. If you have one of these, I highly recommend you play with it. Just do a little thing on an LCD panel, a 16:2 LCD panel, and get the temperature, get the humidity, and just kind of get started in the world of IoT. Now, in my project, when I originally expected to be putting sensors all over Alaska, I thought that I was going to be using these, and I used a couple of them at times, but what I wound up using instead were these DS18B20 sensors. And these, I have a love-hate relationship with these, but it's mostly love. These, especially for something you get in China, this is very quality. These things run about $1 a piece. They have this hard metal cap on the end. Now, if you were to see the actual DS18B20 sensor, there's it's just a really tiny sensor, but for some reason they ship it a lot in this well, and this really is a handy package. For one thing, these have proven to be very robust. In Alaska, we buried them underground in a PVC pipe, and basically every foot we would have one of these sticking out and would tell us how deep the freeze was in the ground. You could just poke this little part of it through the ceiling and use it as a temperature sensor in a building. Another thing we would do with these is there's a plumbing part called a Thermowell, and basically what it does is it allows you to not stick this in the water, but basically inject it into the pipe so that the water coming past it will hit the copper of the Thermowell and transfer the heat here, and we could see how much water or what the temperatures of the water coming in and out of the boilers and things like that. So I've run a bunch of these sensors. Now these things have a very unique and not obvious interface. It's called the one-wire interface, and the way these things work is that in theory, every single one of these sensors that has been produced has its own unique serial number. And so the way that it works is you've got power, you've got ground, but then you also have this yellow one wire interface wire, and essentially you can string hundreds of these along, and as you probe out, you can figure out which one is which over the one wire interface. And so you can't just stick these out there and deploy them. You need to hook them up, and I probably have a sketch. I might paste a sketch in this video description here, but you need to figure out one at a time what the sensor serial number is, and then you use that to query it from the Arduino. And so I would make a giant spreadsheet, and I have hundreds of these things in there, at least 100 in there, and every single time I get a new sensor, I would tag it, and so that I could go back and query this sensor later. So pros and cons, basically the DHT1122s you just hook right up and go, but these things are a lot more robust and a lot more flexible. There's different ways to power them. You can use parasitic power and all kinds of things like that. I'm not going to spend a ton of time talking about this. There's a lot of videos on it. I may make another one, but I really love these sensors. Now I think I've got another temperature sensor around here somewhere. Now I do have this one, which I ran and grabbed out of the bucket by my laser cutter. And the way this one works is I'm powering it with 12 volts here, I believe, and could be not, yeah, 12 volts. And this is a temperature sensor where you can drop this, in my situation, like I'm dropping this in the water for my laser cutter, and you can set an alarm to trigger this relay on or off. And so right now I'm just using it primarily as a temperature sensor, but my thought was that what you could do is if the temperature reaches above a certain amount, you could turn on alarm, you could turn off the laser cutter itself. There's a lot of different things you could do with this, that basically if the temperature reaches above or below a certain point, you can use it to trigger this built-in relay. Not Arduino related, but this was really cheap. It was like $1 or $2, and so really happy to have that. I'm going to do an entire series on hacking my laser cutter, and so this will probably be in there sometime, so we'll follow up on this one in a little bit. One of the things I realized in the middle of recording this video is that I have a lot of these sensors already hooked up on the coding array board. If you haven't seen it, I have an entire video series on the coding array, very sweet teaching tool. But we've got the DHT11 right here, which is showing 23 Celsius and 58% humidity, and I could probably heat that up relatively soon. It doesn't check the temperature super often, but you can see the DHT11 in action. Right here, you can see the humidity going up and the temperature going up. Now, the next device I have are these little speakers, or probably more accurately, buzzers. And as you can see, I've got a bag of them here. They're really cheap. On the coding array, if I can find my little magnet, you can, this magnet's not very strong, but you can trigger this mode. And I use the pitches.h library to play these sounds. And I feel like there's also a way to play the Mario sound. I don't remember. But so these little speakers are great for adding little sound effects to your projects and things like that. The reason they come in active and passive, I generally tend to use the passive ones. Just 2 wires to hook them up, play little sounds. They're nothing fantastic. But what I use them for, and this is my first prototype from a while back, this is a device that I made, horribly printed, called the IT Waker Upper. And what it is, well, let's take it apart. Let's take a quick look at it. Again, you're looking at version 1.0, but this one here, actually this is probably 0.10. This thing here is an Arduino Nano with an Ethernet shield on it. And so if I pull this apart, again, we're bulging here a little bit. If I pull this apart, it's fine. Yeah, the button's still there. I have one of these little buzzers attached to the Nano that has an Ethernet shield. I've just got some glue here to kind of hold it in place. But what this does is it sits behind my TV, powered by USB, attached via Ethernet. And for my clients that are willing to pay for the privilege, they can use a dashboard or an app to push a button and wake me up in the event of an emergency. Now, I don't keep my phone in my room. I don't want the notifications. I don't want the thing lighting up. I don't even want to wake up and check my email in the middle of the night. So the only way to get in touch with me in the middle of the night is to trigger the IT Waker Upper. Now, my plan is to do a little series on this and maybe even open source the software to where you guys can have your own dashboard and you can decide who can wake you up and when they can wake you up and which IT Waker Uppers will trigger. But this thing runs off of the buzzer that's on here and that's here. Now, this is not in the coding array, so we're just gonna dump this out to the side. These two are related, and if you have seen my ESP32 shooting gallery,
get ready.
then you are familiar with these parts, and you can see it. This box really needed to be reorganized. So this is a little sensor that detects whether it has been hit by a laser, just kind of right in the middle there, and it's got this little LED, which is kind of handy because it gives you an idea of where to aim. But these just take 5 volts and ground and have one wire that will act as an input. There it is, that's the side to use, and it will tell you if it's been shot with a laser. And these things here are little lasers that, let me rip this open here. These are the lasers that I put in the middle of my laser gun to fire off either on my giant duck hunt wall. But anyway, so you can come down here and see that like in that time I hit 5. Or on my ESP32 shooting gallery and stuff like that. So these are, they're dangerous, but I like the way they work and they're generally pretty bright. Now one of the things I actually do like about them is they're not attached to the PCB so much that they can't be moved. Now I wouldn't move them every day, but what I do a lot of times is I'll mount this thing and I won't even really worry about getting it that straight because I know I can kind of very slightly adjust the aim once it's in the device that's shooting the lasers. So these are laser sensors and lasers. Now, you know my hatred for the MQ5 and whatever gas sensors up there that are coming in a lot of these kits and how I think they're junk. And I wouldn't quite put these at that category. But this is one of these little ultrasonic sensors, and you'll see that as I put this thing over the sensor down here, you'll see that on the screen it's giving you a difference of distance and stuff like that. And I think that these things absolutely have some use. Really good for telling if a door has been opened or if something has passed in front of something for the most part. But they're not super reliable, they're not super accurate. And it's more, I think my hatred of these sensors more comes from all of the posts I see on the Arduino thing, like, hey, I put this on the end of a cane and I invented a smart device for blind people. You will kill blind people if you expect them to depend on the HC-SR4 ultrasonic sensor. It's a cool sensor, but this is in the realm of a toy. Now, I could see if you have a factory or something like that and you're relatively close and you just want to know if something went past it, that's fine. But the problem is I see these things all over the place in applications where safety is a concern, and this is not something you want to use where safety is a concern. You really just don't. So that being said, I might mount one on the front of my 200-pound robot just for the heck of it, but you know, be careful. These are fun little toys. They'll tell you roughly how far something is away, but they are far from foolproof. I have some of these PIR sensors, and I don't use these a ton. Pileofstuff just did a breakdown on a nightlight that I sent him, and gets into a little bit about how PIR sensors work. What I did with this particular one exactly is this was in my escape room, and so there was basically an obstacle where you had to get within a small area and not move for a certain amount of time, and this thing would look at you, and if you moved, then the timer would start back over. And there were different things that we could do to entice you to move, like, you know, accidentally squirting you with water and stuff like that. But so these are good for triggering stuff on motion. You've all seen them before. They're cheap, they're about $1. They're easy to hook up, easy to deal with. Yeah, so that's the PIR sensor. Let's see what we got here. So there's a couple of light sensors, essentially photocells. Now these are a little bit more sophisticated. You can let's see here. You can set the sensitivity on this with this little dial. This can be an analog, which will give you basically an amount, or it can give you a 0 or 1 when you pass a threshold. So these are kind of nice. They're not something I use a ton. There is one of these photoresistors, and that's actually what they are. They're photoresistors, so the amount of resistance changes based on the amount of light they see. So right now it is bright. If I cover this, it says dark, and there's kind of an intermediate in there somewhere. But this is a photoresistor light sensor photocell, super cheap, super handy. Let's look at the next one. So these are another thing that I kind of put in the realm of a toy. I could see a few little uses for them, but I never got accurate enough results because they depended so much on the lighting. But this is a color detector where you point these 4 LEDs at an object and it gives you a color reading back. Now this is the technology itself is tried and true technology, but this implementation is nothing fancy. Now somebody might come out and tell me where they're using this in something industrial, and that might be true. And I could see you using it to tell if something was black or white or maybe blue, or some very broad strokes. But I didn't have very good use with these things, and my thought was in an escape room, this could tell you the color of the object that you put in front of it, and maybe putting the right color object would work, but it just never got good results with these. These are pretty common, and I have a project coming up with these. So these are some various water detectors, and they have little copper traces on them and look to see when or tin traces, looks like, and they will tell you when water is connecting two of these sensors. Now what I use these for is for some water games to tell if they've been shot with a water gun, and so I will show you that in action. I need to do that for this summer, so I'm going to make a game out of this this summer. But I've got a couple different models of these, and they're cheap and they're handy, and the real use for them is people use them to put them under sinks and stuff like that. Now because of that, I guess you could put it face down like this and just look to see if there's any water under your sink, and if water makes it under here. I've always felt like the headers should be on top, but anyway, that's just my personal preference. This one does actually have the headers on top. So, but these do have a use, and we'll play around with those in a future video. I have another sensor I've not used. It's a what is it? Is a TENT 6000 light sensor. Oh, that one's got some funky soldering on the headers. This is just another little light sensor. Never used it. Can't tell you very much about it. Next item I have are these little MP3 players, and let's see, they're both sealed, so I'll just open this one. And this is kind of a cool little device. I feel like they're by DF Robot or something like that, or at least they use their DF Robot library. They have room for an SD card on them, and they communicate over serial. And so the way this works is you just basically send a serial command to it, and it will start playing through a couple little pins the track of your choosing. And I feel like you either number the MP3s or different folders and things like that. It was a little tricky to get that set up to begin with. What I use this for is I had a friend who asked for some basically to make a joke hotel lobby phone that if you picked it up, it would play a dial tone, and as you started dialing, every number would play a different joke. And so I took the keyboard matrix of the phone and read that out with a meter, figured out how to basically steal the signals from the keyboard matrix, and would make the phone play different jokes in the earpiece. And so these are really handy. They are 3.3 volts, so if you're going to run them with an actual Arduino, you need a logic level converter, and these are very not 5 volt tolerant. So a lot of things you can kind of put 3.3, put 5 in it. This you definitely don't want to put 5 volts in it. So that is the MP3 sensor. One other sensor that was in the box that just happened to be in there is this fingerprint sensor, and these are very weird. You would kind of expect that this would shoot out some fingerprint data, but that's not how this works. I think you can store like 200 fingerprints in the device itself, and you do different things to register the fingerprint, and then once you scan, it tells you, I think it tells you which user the fingerprint belongs to. It doesn't actually tell you anything about the fingerprint itself, and these are like a couple bucks. This one I actually used for a project. I do some rapid prototyping where people just kind of show up and have me build something, usually the same day if not the next day, and in this case they needed a device that could be operated with either a remote control or a fingerprint, that when you opened up the back of the car and you put your fingerprint on the sensor, if it was correct, then the amp, then the basically the floor of the trunk would release and come up and out with all the amplifiers and stuff on it. And so they wanted some kind of cool effect, and this was the sensor I used. I had to get two of them just so that I had one to test with, and if I had to debug, I had one at my house and they had one in their shop. So yeah, this is the cheapo fingerprint sensor. This right here I think is the last one, and this is one that has definitely given me some headaches. These are water flow meters, and they have a Hall effect sensor in here that basically, I've never taken one apart, but I say it's got a Hall effect sensor. Let's take it apart. No, wrong one. Let's go here. So the idea with these things, and when you buy them, they're like $6 or $7, I think, if I remember correctly. When you buy these things, you sort of think to yourself, wow, I can make my own water meter, and they come in different inlet and outlet sizes. So they're generally 1/2 inch or 3/4 inch American standard pipe threads. But the the idea is that you can kind of make your own water meter. I didn't find them extremely useful on that. What I did find them useful as is that they could generally tell you if water is flowing or not. Let's open this puppy up. Okay, so this has got to be a magnet up here. I mean, that just feels like a magnet. Oh, okay, I see what's going on here. So let's see if this comes out. So you have this little wheel here, and this spot is obviously different, and I'm guessing maybe that prevents the magnetic pulse. And so the idea is that as water flows through this thing here, then it hits a spot on the magnet, or maybe that is the magnet. I'm not exactly sure. Can't really take this part apart, but as this thing spins around and water flows through it, then you're going to get a pulse for every revolution. And so what you do is you use an interrupt generally and try to detect how many pulses you're getting in a given amount of time, and use that to figure out how much water is flowing. Now, I've found them to be extremely frustrating to work with. I found them to be relatively inaccurate. So in my opinion, the best use on a sensor like this is to use it to tell not how much water is flowing, but if water is flowing. And so this could be a good way to detect if there's a leak in your house. But what we used them for in Alaska was, if you've never been in a place like that, the water pipes freezing can cost you thousands of dollars. And so there's two very important things if you have water in a building. You need to make sure you have heat, and then you need to make sure that the pipes have not frozen. And so the way you generally do that is you have a continuous flow. It's harder for water that's flowing to freeze. And so at the end of either your house or the end of your last building, if you have a bunch of buildings, you have water coming out that side. And what you want to do is you want to detect that if water stops flowing, or if water slows down from flowing, you need to know that ASAP. And so that's what this is good for, to tell you if water is flowing or not, and you know, to some extent, how fast is it flowing. But that's about the best usage I've got out of these things. So that is my water, sound, light, and temperature box. Tell me what you think. You have any comments? Leave them below. Subscribe, hit the bell. I appreciate all the kind words that people give in the comments and the questions and stuff like that. So yeah, hey, thanks for watching. Have a great day.